Okay, now I take the attendance. Number 5 is missing. Number 8, no number 8. No 14. Number 20, missing. Number 25 missing. Okay, 3 missing. Number 5, number 20, and number 25. Okay, please in the chat say good morning to Mr. Lee. Mr. William Lee is with us today. Say good morning, Mr. Lee, in the chat. Last time I just finished the first part, and this one will start 1.2. The laws of reflection. The laws of reflection. I've just only go through this to this slide. So all three on the right hand side of the photo, you can see all the light reflection from the wick. We normally use the standard wick for the beam balance, and we can see that the leftmost ones have this very clear reflection, but not the second one. And also the last one is further, just because we use the sandpaper to whip the surface. The second one slightly. The last one is whipped strongly. So we know that this is just to make a very rough surface. This is something very strange maybe. Because, why? Sometimes we use a sandpaper to rub on something. What do you feel on the surface? Most probably, you may think that after the rubbing by a sandpaper, the surface will become smooth. Yes, it is true. If it is on a stone surface, if this is on a wood surface, after you rub with a sandpaper, it becomes smooth. You touch with your hand, you will become smooth because this surface is a file folder. It is already very smooth. But if you use the sandpaper, you know the surface is very rough, and you scratch on it, it makes a lot of scratch. So in this case, if you use a sandpaper to rub on the file folder, it will become rough, but not smooth. Not in the daily practice. When you rub a sandpaper on a stone, on a kitchen stone, or on a piece of wood, that's how we feel it. We find that on the rightmost side, the light seems to be given in different direction, but you cannot see a very clean image. The middle one is somewhere between the other two extremes. The first one is a smooth surface. You can see a very clean image. So this will be explained later about the reflection. But in this case, we want to find the property of reflection. We always use a very smooth surface. How can we obtain a smooth surface? Of course, we want to reflect light. We always use a mirror. A mirror, of course, is a layer of glass with a metal coating behind it, most probably, with a very thin layer of glass with a metal coating underneath it. But normally, we know that most of the light reflected from the back side of the mirror. That is the other side of the glass. But normally, we draw the picture. We ignore that. We assume that the light are reflected on the upper surface of the mirror. So how to make a light ray? Of course, we can always use a laser pointer. But a laser pointer, it gives us a very single line. It is, although you can see that, but it is very difficult to show in an experiment like this picture, unless we smoke and make some smoke around, and maybe the smoke will reflect the pathway of the laser beam. Otherwise, you cannot see clear the laser beam. So we'll make use of a ray box. As I mentioned last time, the ray box is used to introduce you the concept of converging rays, diverging rays, and parallel rays, or parallel beam, diverging beam, and converging beam. Use a ray box. Now we always also use a ray box. A ray box, we have a convex lens inside, so that the ray go outside will not diverge horizontally. So all the horizontal ray will be focused into one single line. But there is no convergence in the upper and the lower part. So the light will a little bit diverge in the vertical plane. So the light will give some light shown on the table. Now this picture on the left is a picture when we make a photograph on top of the experiment. So you can see that the light gives out a ray, and you can see that the ray seems to become dimmer and dimmer as it goes through that. As it goes, it becomes dimmer and dimmer because there's some kind of divergence in the vertical plane. So when a wave diverge, the more you go, the wider it spread, the less energy it will have in a single direction. Of course, for laser beam, just give out a single line, the intensity will decrease very slowly because I don't think the air can absorb much of the energy in a laser beam. So the laser beam can go very far away, 100 meters maybe. And on the right hand side, please note that very important point that for ray diagram, for the second part, the second term, we have this optics. You are not asked to do many calculations, but instead you have to do a lot of ray diagram drawing. So for ray diagram drawing, every single light ray, you have make an arrow for that, indicate the direction. And normal practice is one arrow is enough, not two arrows, not three arrows, one arrow for each straight line. Although this is a single ray, but because it's refracted, this is refracted. So the refracted ray, it goes in another direction. You can draw another arrow. So one arrow for one straight line. So this is a reflection. Of course, this is very clear. But in order to discuss about the reflection, we have to give it some terms. Otherwise, it's quite difficult to describe and to state a law for that. Okay, suppose we have a light ray come from a ray box, either from a ray box or a laser pointer. It's okay. A light ray. So we have a line draw, and it hit on a mirror at a certain point. And we make an arrow to show the direction. And what do we call this light? This is the incident ray. Don't give me incoming ray. The ray it come from the ray it come from the light ray box. For technical term, incident ray. Make sure that you use incident, not incidence. Later we'll have another term use incidence, but now we use incident ray. Okay, you hit on mirror, and we have a reflected ray. It's a reflected ray leaving the mirror, and you can see that it should be at the same point. The point it hit the mirror should be the starting point of the reflected ray. It will not submerge the water in the mirror. Of course, for swimming, you dive from a platform, you hit the water, and you go into the water, and you may come out of the water at another point, because your body just come inside the water and then come out at another point. So the point you drive in and you come out of water may not be the same point, but for the light, it will not go inside. For example, as I mentioned, that we assume the light is reflected on the upper surface. In practice, in reality, the light will go inside the glass and then hit on the silver surface on the other side, and then reflected back, and it come out of the glass. So the incident point is a little bit, reflected point is a little bit away from the incident point. But for this, for this syllabus, we always assume that the light reflected on the upper surface, not in the inner surface. This is a normal. Because if we want to use a normal to define the angle, please note that this is an imaginary light. It is not a light ray. Very important that all emergent light should be used dotted line to draw, especially later when you draw the image in a mirror. I can say that each year, almost 1/3 of the student, make a mistake of drawing a solid line, draw a solid line for the image, for the virtual image. It should be dotted line. Why normal? Why using normal? Because sometimes a reflected surface may not be plane. It may be a curved surface. But the light can still hit on any point on this surface. And this is now quite difficult to define the angle between the surface and the light ray. So we will use a normal instead. Any surface on a point, we can always introduce a normal. For example, this is my mobile phone. This is the ball pen. This ball pen, the normal is perpendicular to the plane. That is perpendicular in all directions, 180 degrees. For example, now, you see from me, it seems to be perpendicular, but if I turn in the other side, it is not. So for normal, it should be all direction perpendicular. When you see turn around the plane, you can see 90 degrees in all directions. This is the normal, the true normal. Otherwise, if you make an angle, you may see that it's 90 degrees perpendicular in one direction, but not in the other direction. That is not normal. The normal is an imaginary line always perpendicular to the surface, even you see a different direction. And this one, we define an angle of incidence. That is the angle between the normal and incident ray. Now you see the difference. This is the incident ray, and this is the angle of incidence. The difference between a noun and an adjective or adverb. And the next one is the angle of reflection, not angle reflected. So don't give me reflection ray. It should be reflected ray. Angle of reflection. So after we define this term, it is quite easy to give you the first physics principle for reflection. That is what we call the laws of reflection. But before that, we can do an experiment to find that before we can give a conclusion. Now you use a ray box. You can see that a projector. For this experiment, we use a full circle projector. That is all 360 degrees. We take the 0, 1 as be the normal. The 0, the reading 0 be the normal. And this full circle projector, from this 0 point, both left and right, you can see it's starting from 0, 10, 20, 30, up to 90, up to 180. Now you can see the light ray hit on the mirror, and the point it hit on the mirror should be the center of this full circle projector, the center of the full circle projector, so that the incident ray is in fact passed through the radius of this full circle projector and hit on the point, and you can see the reflection. You can see clearly the reflection. And then we measure the angle of reflection. Direct ray, this is the angle of incident, or for example, you read the angle incident at 30 degrees, and then you can measure the angle of reflection and want to find the angle of reflection from different angles. But of course, you know that what will happen? The two angles will be equal. So
Goodbye,
now we
sir.
come, yep.
Okay, the student just thought, seen my words in the chat room. Oh, thank you, Mr. Low. I'm going to leave. Okay, thank you. Bye bye.
Goodbye.
Thank you.
佢好忙，不過可能算啦，睇咁多堂悶死佢，冇辦法啦。校長話要所有 panel 一定要睇晒所有先生所有堂，我嚟做一個即係叫做學校嗰個 check 啊。諗下啦，每一年我教咗成喺呢度教咗廿幾年、24年，喺度教咗24年，年年都先生要睇堂，嗰啲先生睇到悶晒啦。每一科嘅 panel chairman 都要睇個先生一次，你諗下悶唔悶到抽筋啲先生？試過啲 panel 嚟睇堂嘅時候，睇到自己瞓着咗喺度。喺後面恰着咗，校長都睇過啦 ，Brother 睇過啦，校長都中眼瞓啦，所以有呢樣嘢就有估講啦嚇。不過估就講到今 part 啦嚇，都夠鐘落堂啦嚇。 OK， 打個 goodbye 走得。
拜拜，希望。